sample t-test. So in this experiment, half the people were told that they each would be responsible for the individual meal cost, and the other half were told that the cost would be split equally among the 6 people at the table. And so in the table, we have a summary of 2 different samples. We took a sample of 24 individuals who thought at the end of the meal that they would be paying for the individual cost of their meal, and we took another 24 that believed that the ticket would be split equally among the 6 people at the table. And so we're trying to figure out whether or not we have evidence here to suggest that those people that believe that the meal would be split equally would tend to spend more than those that thought that they were going to be paying for their own meal. So here, mu sub I represents the mean amount ordered by the people that thought that they would be paying for their meal individually, and the mean sub S is the mean amount at the table when we felt like they would be splitting the bill at the end. So we're trying to find evidence that the individual mean is less than the split mean. So I've illustrated here how we would compute our test statistic, and I have our p-value calculated. And so we have our conclusion, but I want you to look at StatCrunch to see how we compute the test statistic and get the p-value. So I'm going to press stat. We're doing t-statistics, and it's a 2-sample test, and we have a table that has the summary of the data. So first I'm going to enter in the summary statistics as I have them from the table. So the sample mean for the first, the individual, we have 37.29. The sample standard deviation is 12.54. The sample size is 24 in each case. The sample mean for the second, 50.92. The sample standard deviation is 14.33. And again, the sample size was 24. Now, depending on whether the problem states assume equal variances or not, if we assume equal variances, we would press this for pooled variances. Here I have not done that, so I will uncheck that. Here we have our null hypothesis, that the 2 are equal or their difference would be 0. And here I have that the first is less than the second, or in this case, the first minus the second would be less than 0. So I'm also going to plot the p-value. This will give us an illustration of what we're looking at here. And so if I press compute, it gives me a nice table here where it's conducted the test. And if you notice, it gives me the test statistic. So the 2 decimal places, that would be negative 3.51. And the p-value, rounded to 4 decimal places, is 0.0005, which is what I have over here, just not rounded quite to 4 digits. Now I said that I checked the box to plot the p-value. If I look at the second page of the output, hit the arrow key, they've plotted the negative 3.51 over here to the left and shaded in the area in that tail. And that area in that tail is the p-value, 0.005. So what I witnessed, had the 2 means actually been equal, was well below 0. And so here we have very strong evidence that the mean meal cost when individual checks are expected is less than the mean meal cost when the bill is expected to be split equally among those at the table. So here's an example of a 2-sample t-test and how to use StatCrunch to help us with the calculations.